We talked about a lot of interesting things this week, so let's go over them fairly quickly and then look at a program that demonstrates some of the important stuff you're going to need to do the homework. This week we had four main topics. We started with variables, and when we talked about those, we first talked about how to name variables, and then integers or whole numbers and how to use those. Floats are numbers that have a fractional component. I talked about why you sometimes want to use an integer and sometimes you want to use a float, and a curious property of integers, which is when you divide two integers, you always get an integer. I talked about some of the ways that you can make sure you always get back a floating point number, which is important for animation when you want things to look smooth. There were three supplemental videos in this section that talked about longs, scientific notation, and doubles, and these are techniques for representing very large or very small numbers, or numbers that need an extreme amount of precision, and ways to type them in so that you don't have to sit there and count a huge number of zeros. Then we discussed the basics of animation and how processing uses a kind of a master clock called frame count, an integer that tells us how many frames have been drawn so far. By tracking frame count, we can change how things look on the screen, creating animation. We talked about the ways of programming that will make your life easier. Commenting your code, using processing's color coding to keep track of what you're typing. Dealing with errors is absolutely critical because you'll be doing it all the time. We discussed how to interpret an error and how to print out your variables so that you can see what it is you're computing, and then some other ways of debugging your code to make it work. And then we covered some ways to customize the processing environment by setting up your preferences to change, for example, the font size, create huge programs by using tabs, or even use an external editor if you're not crazy about processing's built-in editor. That brings us to this recap, and the next video will be your homework assignment. Before we dive into the homework, let's take a look at putting some of these ideas into action and create a little animation. So here's a program, and it will create an animation. So let's go through this one piece at a time. At the top, we have void setup as usual. And inside of setup, there are just two calls. One to create the size of our graphics window, which I'm making 600 by 600, and a call to smooth. And that's it. That's the end of setup because you can see the closed curly brace. Then we have draw, and you'll see that there's a bunch of stuff inside there. First, we set the background color. Then I create a floating point variable named CX for center X. I'm going to draw an ellipse, and the ellipse I know takes four numbers, the center X, center Y, width, and height. So I decided I'm going to call my first variable for center X CX for simplicity, and I give it a value that changes over time. It starts out as 100, and then I'm going to add something every frame. And what I'm going to add is frame count over 5. So it will go up very slowly as frame count goes up. And remember, I've had to divide by 5.0 so that that number goes up smoothly and it doesn't jump up by 1 every 5 frames. Then I created a variable called CY, and that's the Y value of the center of the ellipse. And I made that CX plus 50. Well, we just computed CX in the line above, and so now it has a value. I couldn't have put this line above CX. If I swapped the lines float CX and float CY, tell you what, let's actually do it and try to run it. And you'll see what happens. I'm going to take the line for CY and I'm going to put it above the line for CX. And I'm going to try to run it. And you'll see we get an error. And if you look at the error message itself, it says, cannot find anything named CX. And you might think, well, that's ridiculous. It's right under you. But remember, the program is being executed one line at a time, top to bottom. So when it sees float CY, it hasn't seen float CX yet. It doesn't know what's going to come along in the future. So if we want to use CX this way, we will put the line for CY after the line where we create and assign to CX. So now CX has some value, and I just add 50 to it. So now Y will move with X. The ellipse will move down and to the right at the same speed. Then I just create a variable called w for the width and a variable called h for the height, and they both start out at 100. The width gets smaller, and eventually it's going to go to 0 and then go negative, and the height just gets bigger and bigger. And I draw the ellipse. And every frame, the stuff inside of draw gets evaluated, and it creates a picture. So let's go ahead and run this and see what it looks like. So there's our ellipse. The width is getting smaller and smaller. Now the width is negative, but that's okay. It just draws the ellipse as it goes through 0. And now the width is getting more and more negative, which makes it wider. Height's going up, and the thing is moving down and to the right. So that's great. Now I'll just add a couple of things to give this program a little more visual interest. The first thing I'm going to do is I'm going to change the color over time. So tell you what, I'll create a variable called R. Now I can't call it red. You'll notice that that gets color coded into a processing keyword color. We haven't talked about red, green, and blue yet, but red, green, and blue are all reserved keywords. So we have to use something else, anything except red, green, blue. I'm going to keep it super simple and just say R for this quick demonstration. And I'll make R be just frame count over 5. And you'll notice I put each one of these divisions within parentheses. You don't need to, particularly with something that simple. But I'm thinking later I might add stuff to this, I might change it around. And so putting the parentheses in now is a way of kind of anticipating the future, thinking, maybe later I want to do stuff and I don't want to forget about the parentheses. And it doesn't hurt, it doesn't slow anything down, so it's superfluous. Now green, I'll start out at 255 and make it get darker. So we'll make that get darker at the same speed that the red is getting bright. And tell you what, I'm going to make the blue value be twice the red value. And now I'll set the fill color to RGB, and we'll run that. Great, so now the thing is changing color as it moves, and it starts out as that garish, very, very bright green. I'm not trying to pick pretty colors here. I'm just cranking out little number tests. And you can see it sort of turns more and more purple as it goes. So that's really nice. Let's do a couple of other things to sort of make this a little bit more interesting. Now you'll notice that the first line of draw calls background. That means that the first thing that happens for every new frame is that the background gets cleared to a constant color. Let's take that out. What will happen? So I'm just going to remove it. I'm going to comment it. And I'm going to run the program again. And now each ellipse just gets drawn on top of whatever was there before. And it doesn't look terribly interesting in the upper left because we're drawing the black line around the ellipse and they all just sort of stack up. And now the ellipse is just getting bigger and bigger and it's overwriting everything that went before. In part 2 of this video, we'll see what happens in this animation when we turn off the black stroke around the ellipse.